Welcome to this explainer where we're going to uncover exactly how ancient India transformed early myths of the cosmos into some truly rigorous mathematics. We all look up at the night sky and feel that sense of wonder, right? Well, thousands of years ago, that exact same wonder was actually the launching pad for some of the most sophisticated scientific breakthroughs in human history.
To really get a sense of just how deep this goes, you just have to take in the sweeping, incredibly precise geometry of the Jantar Mantar Observatory in Jaipur. Even without modern telescopes, ancient Indian astronomers were building these massive architectural instruments to track celestial bodies with astonishing accuracy. It's this beautiful physical reminder of how deeply astronomy was woven right into the everyday fabric of their society.
Now get ready for this, because this fact absolutely blew my mind. Was the groundwork for calculus actually mapped out in India a full century before Newton and Leibniz? The answer is a resounding yes. The infinite power series of trigonometric functions, literally the building blocks of calculus, were discovered way before the European scientific revolution. And throughout this explainer, we're going to see exactly how they got there.
So here is our roadmap for today. We'll start with why astronomy mattered, then move into the Indian calendric system, explore the science of eclipses, and finally, meet the pioneers of Indian astronomy.
All right, diving right into part one, why astronomy mattered, spanning survival, society, and omens.
You see, for ancient Indians, tracking the sky wasn't just some abstract, academic stargazing. It was about sheer survival and keeping society functioning. Farmers completely relied on the stars to know exactly when the monsoons would hit so they could sow their crops. Everyday families used celestial alignments to perfectly time marriages and religious festivals. And on a political level, it was literally an early warning system. Kings actually appointed official astronomers to watch the skies for comets or shooting stars, because those were believed to be omens of misfortune, incoming wars, or natural disasters. The sky was basically their calendar, their weather app, and their breaking news alerts all rolled into one.
Moving right along to Section 2, the Indian calendric system, or how they fundamentally mastered time. At the very core of this complex timekeeping system is something called the sidereal period. So, what is that? It's the 27.3-day orbital period of the Moon measured with respect to the background stars. This precise measurement formed the bedrock of their calculations. But here's the catch. Because we're observing this from an Earth that's also moving around the Sun, the Moon's cycle appears to us as 29.5 days. To handle this, ancient astronomers brilliantly divided the lunar month into two distinct 15-day halves, the dark half and the bright half. And this dual approach? It reveals the absolute genius of the lunisolar system used by most ancient Indians. They didn't just pick the sun or the moon, they used both. The lunar calendar flawlessly regulates festivals, fasting days, and auspicious occasions, simply because those events are inherently tied to the moon's phases. Meanwhile, the solar calendar serves as the sturdy backbone for day-to-day life and agricultural routines. It's a highly sophisticated, completely interlocking system.
Now, a super crucial concept to grasp here is the TT, which is the lunar day. And honestly, this can cause some immense, almost comical confusions today. Because a tithi is based on the exact angle between the sun and the moon, it can change at literally any time of the day. Say you calculate the tithi at sunrise, but it officially changes an hour later, different schools of thought will fiercely debate what day it actually is. Because of this exact math, a single festival might actually span 2 consecutive days or abruptly end in less than 1 full day.
Okay, that brings us to Section 3, the Science of Eclipses. This is where rich myth meets pure mathematics.
Let's be real. Eclipses have terrified human beings for millennia, and ancient India was no exception. For centuries, the popular cultural story was that the sun was heavily indebted to two celestial demons named Rahu and Ketu. And because the sun couldn't pay up, these demons would periodically appear to devour it, completely snuffing out its light. When everything went dark, people would rush outside to blow conches to chase the demons away, and they'd offer up charity to help lessen the sun's financial burden. It's such a fascinating, deeply human story to explain a genuinely terrifying phenomenon.
But here is the scientific reality, and it's brilliant. The ancient Indian astronomers figured out that the moon actually has no light of its own, and that eclipses only happen when the orbital planes of the Earth and the moon physically intersect. They called this intersection the line of nodes. And what did they name those two exact nodal points where the eclipses occur? Rahu and Ketu. They literally took the mythological demons and used their names for the precise geometric coordinates where the sun's light gets blocked.
Which perfectly sets up our fourth and final section, the pioneers of Indian astronomy.
the unsung geniuses behind all of this math.
Just to give you a quick sense of the timeline here, this scientific genius progressed incredibly fast. We start with the legendary Aryabhatta in 476 CE, move into the 6th century with Varahamihira, and then make a massive jump to the groundbreaking work of the Kerala school between the 14th and 16th centuries.
The complex observatories built in later centuries beautifully mirror the minds that laid the mathematical groundwork. Take Aryabhatta. The guy was an absolute prodigy. He compiled his highly influential masterwork on astronomy when he was just 23 years old. He introduced large units of time and circular units of arc. And then there's his contemporary, Varahamihira. His genius in both astrology and astronomy was so deeply respected that King Vikramaditya himself awarded him a royal title. He famously pulled together all previous astronomical systems into one single, massive treatise.
And this all builds to perhaps the most jaw-dropping revelation we've covered regarding the Kerala School of Astronomy. Around 1500 CE, an astronomer named Nilakanta actually developed a heliocentric model of the solar system, predating Copernicus. On top of that, mathematicians like Aryabhatta provided the first ever proofs for the infinite power series of sine, cosine, and arctangent functions. They were actively using the foundations of calculus a full century before Western giants like Newton and Leibniz. But here's the kicker. The source text points out that Western historians of science have historically denied them credit for these inventions, arguing they only developed these series for practical astronomical calculations rather than general mathematical theory.
So, based on everything we've unpacked today, from those brilliant lunisolar calendars to geometrically unmasking the eclipse demons, all the way to the massive mathematical leaps of the Kerala school, it leaves us with one incredibly provocative question. How much of our global scientific history is missing its true origins? It really does reframe how you look at the entire timeline of human discovery. Thank you so much for joining me on this explainer through the incredible foundations of Indian astronomy.